Dear students, now let us see this concept. Previously we have studied about accelerating liquids. Now in continuation to this one, we are doing this concept. So analogy of accelerating liquid with accelerating simple pendulum. So for example, if you take this as a car in which a simple pendulum is suspended and it is in rest position. So now if I accelerate this car and if I observe the pendulum from this non-inertial frame of reference, so we know that every accelerating frame is a non-inertial frame of reference, then I have to apply a pseudo force on this pendulum. So therefore, the two accelerations which are acting on this pendulum is, one is G acceleration due to gravity and another acceleration is acceleration due to the pseudo acceleration which is acting on this pendulum. So therefore, the net acceleration which is acting on this pendulum will be called as G effective, and that G effective, it will be acting in this direction. So this is the direction of G effective. So here I can write G effective is equal to square root of, so if this is A, we know this is also A, so A square plus G square. And here the simple pendulum will align itself in the direction of G effective. So therefore what will happen? So this pendulum, so it will align itself in this direction, and this is the direction of G effective. Clear? So if I take this angle to be angle theta, then how can I split this one? This G effective, I can split this one into two components. So if this is theta, definitely I can say this angle is also theta and this is G effective, and this G effective I am trying to split into two components. So this is G effective, this is angle theta, this is G and this is A. So I can write tan theta is equals to opposite divided by adjacent. So here opposite side is A and adjacent side is G. So tan theta is equal to A by G. It means that this pendulum will bend at an angle of theta which is equals to A by G. Now same concept, let us see how we can understand with the help of the liquid which is accelerating. So for example, if this is a tank in which liquid is present up to this level, and this tank it is accelerating with an acceleration of A. Then this liquid also experiences two accelerations in this condition. So one acceleration is acceleration due to gravity and another acceleration is acceleration due to the pseudo acceleration for an observer who is present again in the non-inertial frame of reference that already we have discussed previously. So when observer is present here on this tank and he is observing this liquid, then we have to draw this pseudo force so that we can apply the Newton's laws. So again, the net effect of the net resultant of these two accelerations will be called as G effective. And again here G effective is equals to square root of A square plus G square. Already just like the previous condition of pendulum in an accelerating frame. So therefore here again I can take this angle to be angle theta, and again I can calculate a tan theta is equals to A by G. So if this is A, this is also A, so tan theta is equal to A by G. So here in the previous condition, pendulum has aligned itself in the direction of G effective. But in this condition, what will happen? In this condition, the liquid surface will align itself in the direction of perpendicular to the direction of G effective. So that is, this liquid surface, it will take this type of shape. So not only this top layer, all the bottom layers also, they will be arranged in this direction. This already we have discussed in the previous classes. And these lines, these straight lines, we call them as equipressure lines. Because when liquid is horizontal, every point below this one which are at the same level, they are at same pressure according to Pascal's law. So same Pascal's law here how we can apply. Because this is the direction of G effective, and in this line, the lines which are perpendicular to this G effective direction, all these points should have same pressure. So here pressure is P1, here pressure is P2, here pressure is P3, here pressure is P4. I can write P1 is equals to P2 is equals to P3 is equal to P4. So this is how I can write. Are you able to understand? So this is about the pressure distribution in the case of accelerated liquid. Already this we have understood. So now let us see how we can calculate the relation between length of this tank and height of the liquid column, again in terms of angle theta. So if this is the direction of, this is the liquid column which we are taking here. This is the direction of G effective, which is exactly perpendicular to the liquid column. And here if I draw a vertical line, so this should be angle theta, and already we have calculated this tan theta should be equal to A by G. Now this liquid surface and this what you called G effective, they are at an angle of 90 degrees. So if this is theta, definitely I can say this angle should be equal to 90 minus theta. Now from this vertical, if I have drawn again a horizontal line, then this should be equal to the height of the liquid column. So this is the height of the liquid column, and this is the length of the tank, which we call it as L. So if this is theta, this is 90 minus theta, this is 90, and this is again equal to theta. So therefore, if this is theta, this angle also will be equal to theta in this condition. So therefore, I can say this angle is also theta. Now again here, if I calculate tan theta, then let us see what I will get. So tan theta is equals to, again opposite by adjacent. So here the opposite side is H, and the adjacent side is nothing but L in this condition. So tan theta is equals to A by G, and tan theta is equals to H by L also. So therefore I can write tan theta is equals to A by G is equal to H by L. So this is a very important condition to calculate the angle taken by the liquid if the liquid is accelerated with an acceleration of A. So if liquid accelerates with an acceleration of A, then liquid surface takes an angle of theta with respect to the horizontal. Now let us see this question. A container is accelerated with an acceleration of A. Find the value of A at which a liquid just starts spilling out. So these are the dimensions of the tank which are given. Length of the tank is 5 meter. Water is filled up to a height of 3 meters, and total height of this tank is this is 2 meters, and total height of the tank is 3 meters. So I am accelerating this one horizontally with an acceleration of A. So the question is, what should be this acceleration such that liquid starts coming out of this tank? So let us see how we can do this question. So if this is the given tank which is accelerating with an acceleration of A, then for liquid to start coming out of this one, this level of liquid should reach up to the top end. So it is given that this height is 2 meters and this height is 3 meters. So here level of water should rise by 1 more meter, and if this rises by 1 meter, here level of liquid definitely falls by 1 meter, because this is also a straight line, and liquid level also, curved liquid level also will be a straight line itself. So for example, this is the initial level of liquid, so which is equal to 2 meters. Now this is 1 meter. So that 1 meter I can take here. So liquid level will form like this. So this is the level of liquid which will be formed when the liquid is ready to come out of this tank. So total, this height is 3 meters we know, and here liquid level has fallen by 1 meter, and here liquid level has risen by 1 meter. So this will be the equipressure lines which are existing in this tank. Okay, now I am supposed to find out acceleration. So previously we have already calculated acceleration. How we can calculate? Tan theta is equals to A by G is equals to H by L. So the angle made by the liquid surface, I can take it as theta, and tan theta is equals to this H divided by L. So what is the height of this liquid from this position? So if this is 1 meter, this is also 1 meter, because this is equal to 1 meter. So this is 1 meter, this is 1 meter, this is 1 more meter. So total H value will become 2 in this condition, 1 meter and 1 meter. So H value is equal to 2 divided by the length of the tank is already given as 5 meters. So 2 by 5. So therefore A by G is equal to 2 by 5. So therefore A is equals to G into 2 by 5. So 5 1s are 5 2s are 2 2s are 4 meters per second square. This is our answer. So in this condition, if this tank accelerates with an acceleration of 4 meter per second square, then water is ready to spill out of this tank. Now let us see the next question. So a cubical container with side L is completely filled with water. So calculate the horizontal acceleration of container so that half of its volume of water spills out of this container. So here half of this tank should be completely emptied. Then I want to calculate with how much acceleration this tank should travel horizontally. So therefore a cube, we can draw a cube like this, though this tank is in the form of a cube like this, and this one is completely filled with water. So this cube is completely filled with water. So, and this is traveling with an acceleration of A, and this A value we are supposed to find out. So for example, if you take this tank which is in the form of a cube, then previously tank was completely filled. So up to the brim, the liquid level was present. Now if half of its volume should be emptied, then what is the meaning of this one? It means that the liquid surface is no longer like this. Liquid surface is like this. So this is one half and this is another half. It means that half of the liquid has fallen out of this tank. So therefore, now very easily I can apply, if this is a theta, already we know that, so these are the equipressure lines. So tan theta is equals to A by G is equal to H by L. So A by G is equal to, what is H here? H is the height of this liquid at the end of this tank, and L is the length of this tank. So therefore A by G is equals to L by L, because this is a cube which is given. So in this condition H is nothing but L itself. So L by L. So therefore it is equal to 1. So therefore A is equals to G. So therefore if this tank is accelerated exactly with an acceleration due to gravity, then half of this water will spill out of this tank. Dear students, now let us see the continuation of the same previous question which we have discussed previously. So previously we were supposed to find out the acceleration of this tank such that half of this cubical tank will be emptied. Now instead of half of this cubical tank to be emptied, if I take only 1/3 of this volume of water should be emptied, then what should be the acceleration of this cubical container? So previously only 1/2, that is half of the tank should be emptied. Now 1/3 of this tank should be emptied. Then with how much acceleration I have to accelerate this tank? So that I am supposed to find out. So let us see how I can calculate. Previously, so half of the tank means this much of the tank will be emptied, and very easily we have calculated the acceleration of this tank. Now the question is only 1/3 in the sense, so I can say that only this much amount of the tank is emptied. So, and these are the equipressure lines which are formed. Okay, so if I can calculate this angle theta, or if I can calculate this height h, so length of cube already it is given. So if I can calculate this height, very easily I can calculate the acceleration of this system. Now question is, how can I find out the volume of this emptied water? How can I calculate? So we know that total volume total volume of water in this condition is how much? It is equals to L cube, because side of this cube is L here. So total volume will become L cube. So therefore 1/3 of the volume is emptied. So volume emptied. Volume emptied is equals to L cube divided by 3. Now this is the emptied volume which is present. So if I see this figure, this is in the form of a triangle. So if I observe from this direction, here I am seeing a triangle whose length is L and whose height, let it be h. If this is h, this is also my h value. So this will give the area, and area multiplied by depth of this cube, it will give volume of the liquid which is emptied. So because we know, so this is the shape of the cube which is present. So up to here the volume of water is emptied. So this area multiplied by depth, it will give the volume of liquid which is emptied. So therefore this L cube by 3 can also be written as area of a triangle can be written as half into base into height. Base is L here, height is h here. So this total will give the area. So area multiplied by depth. So depth is, this is a cube, so this length also will be equal to L itself. So here depth will also be L. So therefore I can write it is equals to half L square into h. So therefore L cube by 3 is equal to half L square into h. So this L square and this cube get cancelled. So therefore I will write L by 3 is equal to h by 2. So therefore h can be calculated as 2L divided by 3. So therefore we calculated this height which is equals to 2L divided by 3. That is 2/3 of the length of each side. Now once I can calculate h value, very easily I can calculate theta, because tan theta is equals to A by G is equals to h by L. This already we have studied previously. So therefore A by G is equals to h. What is h value? 2L divided by 3 divided by L again. So L and L get cancelled. So A is equals to 2/3 into G. So this is the acceleration which this tank should be accelerated, such that 1/3 of this liquid should be emptied. Dear students, now let us see the condition of tank rotated with an angular velocity omega. So this is a tank, so around this axis I want to rotate this one with an angular velocity of omega. Then we see that the shape of the liquid which is formed here will be, so shape of the liquid formed will be like this. So this is the axis around which this tank is rotating with an angular velocity of omega. Now the question is, what is the reason that this liquid has taken this shape? So when we are rotating this one with an angular velocity of omega, then every part in this liquid, this experiences two accelerations. One acceleration will be acceleration due to gravity, we know that. And another acceleration will be acceleration due to the centrifugal force which is provided. That is the pseudo force, that is the false force, the fictitious force which is acting in opposite direction to the centripetal acceleration direction. For example, if I take any molecule which is present here, then this molecule of liquid, it will have two accelerations. One acceleration is downwards with its g value, and another acceleration is a centrifugal, which is equals to omega square into r. So this molecule will be experiencing two accelerations. So because of these two accelerations, there will be a net acceleration which we have already defined, which is called as G effective. And here G effective is equal to square root of omega square r whole square plus G square. And already we have discussed that liquid surface will be exactly perpendicular to the direction of G effective. So therefore, if I take this liquid surface like this, surface of liquid, let it be, it is present like this, and this is the axis around which this liquid is moving, liquid is rotating. So if I take a point here, then here I say from the axis of rotation, this r value is 0. R means radius in which the particle is rotating. So here r value is 0. So therefore centripetal acceleration and centrifugal acceleration acting at this point will be 0. So therefore at this point the only acceleration which is acting is only g, acceleration due to gravity. Now if I go to the next point here, here I have g value. Similarly I have a small omega square r also, because this is at a small distance of r, so there will be a small centrifugal force which is acting. So again if I take the resultant of these two, then this will be the direction of g effective, and here g effective will be perpendicular to the direction of the liquid surface, or we can say liquid surface will be perpendicular to the direction of g effective. So that's what we have been studying in the previous classes. Similarly, now if I take one more point here, now this is at a greater distance r here. Now here this is g value and omega square r value will be greater. So here I am representing by a greater vector. Length of the vector is greater because magnitude of this vector is greater, because the distance of this molecule from the axis of rotation has increased. So therefore, now if I take resultant of these two vectors, now this will be the direction of g effective, and the liquid surface will align itself perpendicular to the direction of g effective. Similarly, now if I take this point, here the same g acting is acting here. Now this is at a much greater distance of r when compared to these two distances. Now here the omega square value will be much greater. So this is omega square into r, that is the centrifugal acceleration which is acting on that molecule. Now again if I take the resultant of these two accelerations, then this should be my direction of g effective. Now again if I check the liquid surface and this is g effective, exactly it will be at an angle of 90 degrees. So that is the reason why here the curvature continuously increases like this. So this will be the shape of the liquid which is formed here. And the reason is obvious here. So g effective value continuously changes, its magnitude changes, its direction also changes. So liquid will align itself in the direction of g effective. So therefore liquid will take this type of shape. Now for example, if I want to calculate pressure at this point, so therefore here pressure will be due to two pressures. One is pressure due to height of the liquid column, this height of the liquid column, and one more pressure will be pressure due to the centrifugal acceleration also. So therefore somewhere here I want to calculate the pressure which is acting on this molecule. Then here pressure will be due to two accelerations. So one acceleration will be the centrifugal acceleration which is acting in this direction, which is A, and one more acceleration will be because of height of this liquid column, I will call it as Y. So therefore in addition to these two pressures there will be one more pressure, and we know that it is atmospheric pressure. So total pressure acting at that point should be equal to P is equal to P atmospheric plus pressure due to height of the liquid column, that is pressure due to acceleration due to gravity. So rho yg, and one more acceleration will be acceleration because of this centrifugal acceleration. So and that will be equal to rho L into A. So in this condition L is nothing but the distance of this molecule from the axis of rotation, I will call it as r. So rho r into A value is omega square into r. So this will be the total pressure which will be acting at this point because of three accelerations. So already we have studied this one previously. For example, if this is a liquid container which is accelerating in this direction with an acceleration of A, then in this direction pseudo force will be acting, pseudo acceleration will be acting. So therefore, as I start moving in this direction, pressure increases according to rho L into A. Similarly, if I want to calculate pressure here, then as I move downwards, then pressure increases according to rho H into G. Same concept here also we are studying. So for example, if this is the shape of the liquid column, so this is the axis of rotation. Somewhere here, if I want to calculate the pressure, then here three pressures will be acting. One is atmospheric pressure, and one pressure will be due to height of this liquid column, and one more pressure will be this distance R, because as I move in this direction, centrifugal acceleration continuously increases. So therefore, pressure will be because of three factors: pre-atmospheric, pressure due to height of the liquid column, and pressure due to centrifugal acceleration. So these are the three pressures which will be acting at that position. Now let us see how we can calculate this Y value so that I can substitute in this condition and I can calculate the total pressure. So let us see. This is the shape of the liquid column which is formed here. Now I will draw a tangent to this liquid surface. So this is the tangent which I have drawn, and to this tangent this should be the direction of G effective. So acceleration due to gravity G is acting in this direction. Centrifugal force omega square into R is acting in this direction, where this distance is R here. Now here if I want to calculate pressure which is at a depth of Y, so let this distance be Y in this condition. Now if I take this angle as theta, then this will become the slope of this tangent, and slope can be written as slope will be equal to tan theta is equals to dy divided by dr. So where r is the horizontal distance. Now if I take this angle to be theta, then this angle should be equal to 90 minus theta, because these two lines, they are perpendicular to each other. So if this angle is 90 minus theta, definitely this angle should be equal to theta, because again these two lines are perpendicular. So 90 minus theta plus theta should be equal to 90 degrees. So now same angle theta if I take here, then tan theta can be written as opposite divided by adjacent. So omega square r divided by g. So I can equate these two relations here. So dy by dr is equals to omega square r divided by g. This is how I can write. So after this I can write like this also: dy is equals to dr into omega square r divided by g. So dy is equals to omega square by g into r into dr. So if I integrate in both sides, then y is equals to integration of omega square by g into r into dr. Then omega square by g is a constant, so I can take it outside. So y is equals to omega square by g, integration of r into dr is r square divided by 2. So therefore y is equals to omega square r square divided by 2g. So this is the relation which we got. So therefore we have calculated this y value, which is equals to omega square r square divided by 2g. Now very easily I can calculate. So if I draw this figure again, then this is the shape of the liquid which is formed. So at any point here, if I want to calculate pressure, then this y value already we have calculated. So therefore total pressure will be P atmospheric, and because of vertical column pressure will be rho yg, and from the axis of rotation, so this is at a distance of r, so centrifugal which is acting at this point is omega square into r. So therefore pressure due to this acceleration will be rho into L into A, as we have studied previously. So here L is nothing but r in this condition, this length, and A is nothing but omega square into r, which is the acceleration, centrifugal acceleration. So this will be our total pressure equation. So therefore P is equal to P atmosphere plus rho into, instead of Y I can write omega square R square divided by 2G plus rho omega square into R cube. So this will be the total pressure which will be acting at this point.